Alright, this is my how to read an audio file video. It's mainly for the wave file and only for a certain type of wave, but it's the most common wave, and I'll show you what that means. So anyhow, here's the setup. I have a form with a picture box that is set to dock in parent container, which is the form. So whatever size the form is what size the picture box is. And then I have an open file dialog here. So when I hit play, I have the picture box say click here, and I have an event. When I click the picture box, it opens up the open file dialog, and then I can choose a sound from it. So I'm going to choose from my C drive Windows media file, which all the regular Windows WAV files are within, and I'm going to choose ta-da. And there we are. That is showing the waveform of ta-da, with left in the top and right in the bottom. So that's pretty much it, and I can resize it. And you can see it kind of looks a little weird, but it mostly keeps its shape. That's because of the way I'm pulling samples from the samples, and I'll show you what I mean. So let's go to Audacity here, which is a great program for sound recording and such. And here I also have ta-da open. So if I pull up the waveform here and I more or less compare it to the same size that Audacity holds, you can see that pretty much here at the same point is where the big jump up in sound comes from, and it starts at this is pretty much the same line and ends pretty much the same line. So you can tell this is it right here. And so another example here, I got this big chunk right here on the right hand, and that's down here on the right hand as well. Mind you, blue left, green right. Alright, so cool. That's the wave reader. Let me show you how I made it. Let's go to Visual Basic. And the first thing I want to do is define the things for the picture box, which is the pic, and which is a bitmap, and then graphics, which is for drawing on. Then I want to define storage as a new list of short, and short is a signed 16-bit integer. And then the maximum amount, which is also short, and I use that for scaling the waveform in the picture box. So upon form load, the first thing I do is take the graphics and say draw string of click here at 0, 0, size of 20 in an aerial, and that then slaps it onto the picture box by using this command, picture box one image equals pic. There we are, simple enough. So when you click on the picture box, it opens the file dialog, and upon the open file dialog being okay, which you can create that easily enough by just double clicking on an open file dialog, then I should say something else real quick about that. Open file dialog, when you dump an open file dialog in, it puts in file name as open file dialog 1. You want to take that out because I actually use that later, so you want to clear that first. Anyways, getting back to this. First thing we want to do is actually read that file into bytes, and I have this as kind of an example from another video I've made where we read files in, but simply we're doing a garbage collection, which is basically to clear out any miscellaneous garbage that's floating around. It makes for better file readings. So then we do an IO file read all bytes from this file into WAV file, which is an array of bytes. Now I want to create a memory stream off of WAV file because a binary reader uses the memory stream that is generated from WAV file. And what a binary reader allows me to do is actually take those binary chunks of data and put them into the types that they were originally intended to be easily. So there's two websites I want to show you here. One's from Stanford, and the other one's from, what's it called, Sonic Spot. So I'll put these links in the description for these two websites. But it shows you what like the header of the WAV file looks like, and then the data that comes after that. So I'm taking all these header pieces and their sizes here, and I'm breaking them out into each individual things. And once I read it, it actually clears it from the binary reader. So if I read an int32, it's going to shift everything up. So the next read int32 will be the next piece of data. it won't actually be the same spot. I don't actually give this an index to read in the file. It just simply takes out what it's already read. We don't use too much of this, but I throw them all out here so you can use it and know what they are. Fmt size is used if there's a bigger header than usual. This takes out that bigger header, and then so that leaves data ID and data size. Chunk ID and riff type and data ID are actually strings. They're 4-letter strings, and that is described in this nice little example here. Riff, wave, FMT, data. Those are actually ASCII strings, but we don't really use them and we don't really care. The only time you really would care is actually on data subchunk, where it says data here. Because there's all different kinds of waves, but the main type I've seen is data, which is what I've written my program for. But there's all these other types here. Now, if you want to take this, would be a great starting point, and you could create the rest of these for whatever your application requires for. But I've just made it for the simple data type, as most of them are, for a starting reference. So once we've gotten our data size from the binary reader, we want to start throwing in our samples into my sample list. So I clear the list if there's already one in there, and I say data size -1 divided by 2. Why? Because actually I'm reading all these bytes, and I actually want to read samples, which are 16-bit. Bytes 8-bit, samples 16-bit. So I'm going to go through and add all the samples, reading an integer 16, because 16 bits, and adding it to samples, and that's simple enough. And so the next piece would be to see what my maximum amount is. So as I'm going through this loop, I see if the last sample grabbed, is above max amount. If it is, then dump that into max amount, because I want to get the biggest number. So anyways, the next is draw audio, and so I'll minimize this. Draw audio is this chunk down here, and this is I guess not really part of grabbing the data, it's just showing the data. So the first thing we want to do is redefine the picture and the graphics, because if we did a form resize, then we want to redraw audio, because now the picture box is resized. We have to redefine the pic and the graphics. And that's what the open file dialog name was used for. This makes sure that there is a file actually loaded and being used. If there wasn't anything in samples and it tried to draw audio, it would only give me an error and nuts to that. So you could instead use a boolean that says, if file loader or something like that. I just use if nothing in file name. That's simple. So anyways, the draw audio, the last piece of the puzzle here. Redefining the graphics, like I said, and then we clear the picture box by drawing a black rectangle in it. And then here's where it gets a little complicated, so I put descriptions on all this stuff. But ratio, since I have, say, 100,000 samples coming from this file, and my pic is only so wide, then I want to say, well, how many sample counts do I have? -1, because mind you, this is all 0-based, and the counts and the width isn't 0-based, so I have my -1 to kind of make it 0-based. So the number of samples over the width of my picture, it would give me, I don't know, something in the case of if I have, I did the math already. If I have 10,000 samples and 200 pixels wide, then this will result in 50, so ratio would equal 50. So therefore I use that to grab every 50th sample, and that's why you saw the lines jumping around. So half pic I use to kind of put the thing in the center of the picture. It's just pic height divided by 2. Simple enough. Alright, so let's draw this thing now. For I equals 1, and normally I do 0, but in this case, I'll show you why I equals 1. It's because sample number 1 actually here is 0. It's unused. And sample 2 is actually where all the data starts. So I don't care about sample 1. So I'm starting with the left, and let's see. I meant to fix this, but you can fix this if you really care. It shouldn't be -10. It should be something else. Anyhow, I step through every 2. So I will equal 1, then I will equal 3, then I will equal 5, and so forth. So the reason why is because we're going to grab samples at I times ratio, which is, the 50th one. So if I'm starting at 1, then times 50, I'm starting at spot 50 within samples. So that makes it, if I have 100,000 samples, that makes this the 50th sample of that. And then I use math absolute because these samples are both plus and minus. And so, lost my train of thought. Yeah, I want to show them as all a single direction. So I use math absolute for that. And then I want to put this so I can show the height in a certain area. I take that left data that I just made and I divide that by the maximum count, and then I take the maximum count times 2. Why times 2? Because I actually want this to be, let's see, half pick. I mean, that's, I shouldn't say that. If my left data turns out to be something like, it could be the maximum of, let's see here, 256 times 256, that's a word's maximum data, 655, but since it's signed, we only get half that. So the maximum that number can be is 32,768, and the minimum that could be is negative 32,768. So, but I know that that isn't going to be the case. I have a maximum amount, and let's say the maximum of this certain height of this sound is only, say, 10,000. I don't want to have 20,000 worth of empty space. I want to just bring everything to the limit. So I actually want to do half the limit, and since we're dividing by that, we get to times 2. So this is pretty much the limit divided by half. That way we can put it into half the picture. I hope that makes sense, and hopefully it does. Anyways, we'll move on. Now we want to put it into the actual pick height. So we're taking the percentage times the pick height, and that's pretty much, it should be anywhere from 0.0 to 0.1. So if we take a pick height of, say, let's just throw out 50, then we have a percentage of 0.5. That would give us 25 as the height, and so that's how I keep it within the height range. So then I simply draw the line. I'm drawing a lime green for left, and maybe I did that backwards. It was supposed to be blue on the left. You'll figure it out. So anyways, I as the pick spot, and then I want to go half pick, which is the center of the image. Then I again, because I'm drawing a line here, and then that height plus the half pick, and that'll put it right in the center. Now I'm going to do the same thing for the right side, except I'm using +1 because the audio is actually based off of a left, right, left, right, left, right displayed here. You can also see it here as the right samples are on, here, 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 and the left samples will be on the left side. It makes sense, right? Left, left, left. Simple enough. Okay. So, doing the same thing to +1, and in this case we're using a negative here because we want everything to point downwards. And then percentage times the height, and then we're throwing that into the graphics again, and finally putting that into picture box 1. And there you go. That's the mess that I've created. And just because I've gotten a lot of requests for audio, this is probably the first step in the audio, would be to display how the audio is being shown, and to basically get the audio into your program so that you can use it. So more audio tutorials come since everyone loves audio, and have fun with that.